Hello, everyone. We have experienced some basic operations about TD in the previous issues, and some top components. The most commonly used top components, such as feedback, displays, noise, ramp, level. We now have a very basic understanding of TD. So what we're going to learn from today is SOP component. This group of blue components in our component library. Today, under the guidance of me, let's make this effect of this relatively organic and randomly generated particle in the current picture, which is very simple. Then through this case, we will learn a basic method of using SOP components. Okay, let's first restore the entire interface to our initial state. Now it is a state of empty picture. Let's first create a box SOP. Then we click on the small plus sign in the lower right corner. And Viewer Active. Then we can find that we can interact with the box. But notice that when we click on the lower right corner of the operator, any operation of dragging, zooming in or zooming out the component will not affect the parameter change of the box. No matter how we adjust the perspective, it will not affect this change. It's just to help us better observe. After we click Viewer Active in the lower right corner, we can click and hold the left mouse button to rotate a perspective. We can press the middle button of the mouse and drag it left and right to zoom in, or zoom in through the wheel of the mouse. We can hold down the right mouse button to make a translation of the perspective. Through these three modes of operation, it is actually the same as most of other 3D software. We can make a three-dimensional observation. At this time, we can click W on the keyboard, which is a shortcut key to convert our three-dimensional model into a wireframe form. We all know that the three-dimensional model is composed of this point and surface. After clicking on this W, we can see a good point of it. In order to see some distinctions, we click this Use Divisions. We open its subdivision surface to it. In this way, we can see that our box is subdivided into 3 points, such as a box of 3 by 3 by 3. At this time, we click the right mouse button. We can also see some shortcut options here, such as Home All. We can return its entire perspective to a home position. Also include is such a top front view and the right side view. You can use this right button to make an observation. But after we click on a different view, it can't be dragged, it can only be zoomed in, zoomed out, and moved, because it has been fixed under a certain view. At this time, we click Perspective Viewpoint again. We can go back to the free perspective. Okay, let's click on the Viewer Active in the lower right corner and turn it off. We now have such a model. We want to render it, and we know that if we want to see this model, it's not enough. We need to render it into a flat image so that we can perform it. What we need to render is a 3-piece rendering suite, which we commonly use. These are the 3 components we use in all our rendering operations. Right-click on the opening on the right side of the box. Search for this geometry in the first comp. The second operator is camera. Camera. Let's delete all the previous ones. The third is light. Need a light. We need these three things to render our model. Of course, sometimes light is dispensable. Depends on the material we use. For example, when we give it a line material, the wireframe material doesn't need a light at this time. Lighting can only be used in PBR or other materials that need light and shadow rendering. Finally, we need to render it into a top component. What we're going to use is render. Okay, why is it wrong here now? Because I just deleted that one. It has a camera, and we can see in the render that it can choose which camera to render. Now this is camera 1 by default. So it says no camera comp found here. There is nothing called camera 1 in the whole project. But we have camera 2, and we change it to camera 2. Our effect appears. We have rendered it now, and we see that it is now a wireframe state. Okay, we can turn off the use divisions first and change it back to a rendered view of this light and shadow. We can now see that our cube is rendered. We can generally connect a transform SOP behind the model. Through transform SOP, you can perform some basic operations such as displacement, rotation, and size scaling on the model. For example, I can adjust the first value of translate. Control its x-axis motion, and also change the y-axis motion and z-axis motion. The same thing with rotate is that we can change it to adjust its rotation and size. You can make an adjustment through transform. We add a null after render. Then show it. Click on the little blue dot to show it. Okay, now let's take a look at the geometry component in TD. As for the geometry component, we can see that it also has displacement, rotation, and size scaling, which can also be adjusted. But before that, we directly adjust a component that we input. It is better for our whole project to be organized and tidy. So we generally recommend not to adjust it in geometry. But here we also have a new method to adjust geometry quickly. Instead of adjusting the parameters here. This way of adjusting parameters may be abstract and not visual enough. It's not like 3D software. Models can be adjusted directly to this model. But there is also this way in TD. We can first select the second one in the layout above and divide it into two screens. We can be in the right one or the left one, and we can click on the small arrow above. We click on the geometry viewer. In this way, we can see that our entire right side has become the style in our viewer active just now. Then the one on the right is relatively equivalent to the geometry we just had. We can directly control, translate, rotate, and scale in geometry on the right, which is a visual adjustment method. We click on the little hand button above. We can also use the operations in Viewer Active to do this kind of observation. We can also see the position of our camera here. We can also adjust the position of a camera in the view on the right. I'll talk about it later. Okay, we are now in the little hand state and we can only make one observation, and we choose the second little red arrow. Let's click on the ball on the right. Okay, now if we click on the screen again, we can't drag it anymore. We can select different objects. For example, I have selected the cube now. We can see that this cube has 3 more axes than just now. So just like in C4D, we can drag the axis to move. At this time, in the process of moving, parameter in geometry is constantly changing too. It will be synchronized in real time. Look, translate here. At the same time, when we change the left side, the right side will be directly synchronized back. Okay, translate means that we move the position. Its shortcut key is T. We can click R on the keyboard. This is a shortcut key for rotation. The third one is E, which is a shortcut key to zoom. Is it very similar to our C4D? Okay, we're going to create another geometry on the left side. Right-click and select these 3 components. Ctrl plus C, Ctrl plus V, but we don't want a cube this time, we want to distinguish it from it, we replace it with a sphere, a ball. Let's replace it. Delete the one on the left. Then we slightly adjust one of its positions. Okay. We see the geometry viewer on the right. It shows all of our geometry, the contents in the geometry of one square and the contents in the second geometry. So at this time, we can directly select the component I want to adjust in the right. At the same time, if I adjust it, it will also be synchronized to its corresponding geometry in real time. At the same time, what I just said. We click on the little hand, and then we change the perspective and we find the camera. We also choose the camera. We can also adjust the position of the camera directly to Cam 2 on the left. To adjust the position of a camera through the method on the right, we can understand and adjust it more intuitively. Similarly, like the general 3-dimensional software, we can also change it to, for example, for perspectives, the front view, the side view, and the degree of freedom view in the small arrow below. At the same time, we can also make a quick way to move the camera. Click Save View to here above to select the camera directly. We can synchronize the position of our camera to the position of our current camera.